Hello students, in the 11th chemistry, in the chapter Basic Principles of Organic Chemistry, our today's topic is isomerism. Now, what is isomerism? It is the phenomenon in organic chemistry. In this phenomenon, the two or more organic compounds, they are having same molecular formula, but the different structural arrangement or different spatial arrangement of atoms or groups in the molecule. That means these are the compounds which possess the same molecular formula, but they exist in the two different forms. Such compounds or molecules are called as isomers of each other, and this phenomenon of organic compounds, it is called as isomerism. Now let us look to the tree diagram for classification of isomerism, different types of isomerism. So what is isomerism? Two or more compounds with same molecular formula. Isomerism is classified into two main types. There are two main types of isomerism. First is structural isomerism and second is stereoisomerism. We are going to study all these types in detail. So structural isomerism and stereoisomerism. Structural isomerism is again divided or classified into five types, that is chain isomerism, position isomerism, functional isomerism, and metamerism and tautomerism. And the stereoisomerism, it is again classified as geometrical isomerism and optical isomerism. Now let us study in short about these types first, and then we shall go to every type in details. So structural isomerism, in this case two or more compounds are with same molecular formula, but they have different structural formulae. That means the structural arrangement of the atoms in a molecule is different, even though these molecules or compounds have same molecular formula. Then the types of this structural isomerism, first is chain isomerism. Here different carbon skeleton is present. Carbon chain is different in both compounds, both isomers. Then position isomerism, there is different position of same functional group on the same skeleton. That means carbon chain will be same, but position of functional group is different on the carbon skeleton or carbon chain. Then functional group isomerism, in this type the functional groups in two molecules are different. Their molecular formulae are same, but functional groups are different. Then metamerism, in this case there is unequal distribution of carbon atoms on either side of the functional group. That means on the functional group in different molecules the different number of carbon atoms are present on the two sides of the functional group. And last type here is tautomerism. In case of tautomerism, there is the rapid interconversion of the structural isomers. That means the two types of structurally different compound, it is actually same compound but structures are different, and these two structures they rapidly interconvert into each other because of migration of proton or hydrogen atom from one atom to another atom in the molecule. So it is called as tautomerism, and such isomers are known as tautomers. The second type of isomerism here is stereoisomerism. In this case the two or more compounds have same structural formula, also same molecular formula, but different spatial arrangement of groups or atoms in the space. Spatial arrangement means arrangement in the space, and according to this concept the two types of stereoisomerism are geometrical isomerism and optical isomerism. So let us go to all these types of isomerism in detail with their examples. So isomerism, first structural isomerism. There are 5 different types of structural isomerism. Just now we have seen. First type is chain isomerism. So in this case, I told you that these molecules or isomers, they have same molecular formula but different parent chain or carbon skeleton. That means arrangement of the carbon atoms in the parent chain is different. For example, CH3, CH2, CH2, CH3. It is butane. In common system, it is called as N-butane. 4 carbon atoms in this molecule are arranged in the straight chain. The isomer of this molecule will be CH3CH, CH3 and CH3. Both these molecules, they have same molecular formula, and that will be C4H10. But here the structure of second molecule is branched structure. So 4 carbon atoms are arranged in the manner that 3 are in the straight chain and 1 is in the branching. The name of this second compound is isobutane. So N-butane and isobutane are 2 isomers and they are chain isomers of each other. Second type is position isomerism. In this case, there is same functional group, but this functional group is at different position on the parent chain. That means position of the functional group is different in the 2 or more compounds. For example, but1-ene and but2-ene are the examples of this type. CH2 double bond CH, CH2, CH3. It is but1-ene compound, and CH3CH double bond CH, CH3, but2-ene. Here double bond is in between carbon number 1 and 2 in but1-ene, and in but2-ene it is in between carbon number 2 and 3. So molecular formula is same, but the position of functional group is different. Then third type is functional group isomerism. In these isomers, the functional groups are different. These compounds are having same molecular formula, but functional groups are different. For example, CH3CH2OH. It is ethanol or ethyl alcohol, and its isomer is CH3OCH3. The molecular formula will be same, C2H6O, but the functional groups are different. In first molecule, it is alcoholic compound, so alcohol, ethanol, and this is ether compound, dimethyl ether or methoxymethane is the name of this ether. So different functional groups are present in both of these compounds, so they are called as functional group isomers, and the phenomenon is called as functional group isomerism. Fourth type is metamerism. These are the compounds with same molecular formula. Functional group is also same, but unequal distribution of carbon atoms on either side of functional group. That means here functional group is oxygen, that is ethereal oxygen. In first molecule CH3CH2O CH2CH3, there are 2 carbon atoms on each side of the oxygen atom. In second molecule CH3CH2CH2OCH3, on one side, that is left side of oxygen atom, there are 3 carbon atoms, and on right side there is only 1 carbon atom. So overall the molecular formula will be same, but the structural arrangement is different, and in this case the unequal distribution is observed on either sides of oxygen atom in the ether. So such isomers are known as metamers. Then number 5 is tautomerism. It is a special type of isomerism. In this case, one form of a molecule is rapidly interconverted into another form. For example, here CH, C double bond O. It is keto form of a molecule of a compound. in this keto form, we have this ketonic carbonyl group C double bond O, then alpha carbon atom, it carries one hydrogen atom. Now reversibly it undergoes the interconversion into this molecule C double bond C OH. Now what happens in this case? This alpha hydrogen atom which is present on alpha carbon atom is shifted on oxygen atom in the carbonyl group, and therefore this bond CH bond is shifted in between carbon carbon, and therefore it forms double bond. So carbon carbon double bond, and proton H plus is shifted on oxygen atom, so OH bond is formed. The second form of this molecule is called as enol form. Enol because en means double bond, OL means alcohol. So in the same molecule we have both functional groups, double bond alkene and hydroxyl group, that is alcoholic group. Therefore it is called as enol form, and this first form is keto form because it is ketonic group. So keto form. So such type of isomerism it is called as tautomerism. Second type of isomerism is stereoisomerism. In stereoisomerism we have two types. First is geometrical isomerism. In geometrical isomerism, in this case the two or more organic compounds have same structural formula. Of course the molecular formula is also same, but different spatial arrangement of groups around carbon carbon double bond is observed. So for example, butene. In this case there are two isomers observed, cis and trans. They are called as cis and trans. Cis means similar and trans means different or opposite. So what is example? Butene. Both of these molecules are butene. In first case you can see here methyl groups on each carbon are on the same side. Now if you see the geometrical structure in the space, the arrangement is like this. The methyl groups on both carbon atoms around carbon carbon double bond are present on the same side. That means same groups are present on same side. Such isomer or geometrical isomer, it is called as cis isomer. In the second case you can observe the methyl groups on two carbon atoms are on opposite sides, are on different sides. So around carbon carbon double bond, the methyl groups present, that is similar groups, are present on the opposite sides, and such geometrical isomer it is called as trans isomer. So for butene we have two these isomers, and they are formed due to different spatial arrangement of the methyl groups and hydrogen atoms around the carbon carbon double bond. So such isomers are cis and trans isomers. Then second type in stereoisomerism is optical isomerism. The optical isomers, they are non-superimposable mirror images of each other. Now non-superimposable mirror images means they cannot be imposed perfectly on each other. They are called as non-superimposable mirror images. For example, our two palm, our palm of left hand and palm of right hand, if you try to impose them on each other, they will not impose perfectly onto each other. Such mirror images are called as non-superimposable mirror images. And non-superimposable mirror images are found in asymmetric molecules. They are called as chiral molecules or chiral compounds. Now in this case there are two types of optical isomers: dextrorotatory, denoted by capital D or plus sign, and levorotatory, denoted by capital L or minus sign. And optical isomers are also called as enantiomers. So in this case we can have dextrorotatory, that is D or plus, and levorotatory L or minus enantiomers. For example, the example is here D plus glyceraldehyde and L minus glyceraldehyde. L or minus glyceraldehyde. So this is the structure of glyceraldehyde. CH2OH, CHOH, CHO. This is glyceraldehyde. So in this case, now you can see here Fischer projection formula of glyceraldehyde. CHO group on the top, most oxidized carbon atom, then CH2OH at the bottom, and at the cross point we have carbon, hydrogen to one side and OH group to another side. The star indicates it is chiral carbon atom or asymmetric carbon atom. Now if you see the mirror image of this molecule D plus glyceraldehyde, and if you see the mirror image of this molecule, you will see the mirror image as the second molecule in the structure. So OH group will be on the left hand side and hydrogen on right hand side on the cross point, that is asymmetric carbon atom. And therefore if you try to superimpose both of these images on each other, you will not get it. Therefore they are non-superimposable mirror images, and such isomers are known as optical isomers. They are optically different isomers. They have different optical properties. That is the further part. But such isomers are known as enantiomers or optical isomers. So that is about the isomerism in the 11th standard in chapter Basic Principles of Organic Chemistry. Thank you very much.